Welcome back to our channel. Are you ready for a wild ride through history and space? In today's video, we're diving deep into the biggest geomagnetic storm of the 20th century, the Great Storm of 1921, also known as the New York Railroad Storm. Get ready to learn about fiery tantrums, coronal mass ejections, and the breathtaking auroras that lit up the sky like a cosmic disco. But wait, there's more. We'll also explore the potential dangers of such storms in today's modern, technology-dependent world. So, buckle up and let's get started. Did you know that our amazing sun sometimes acts like a grumpy toddler? That's right. It throws massive tantrums and spews out huge gobs of plasma into space. Luckily for us, most of these solar outbursts are aimed away from Earth. But when the sun's fiery vomit does come hurtling our way, it can cause some serious trouble, like geomagnetic storms that lead to power outages all over our beautiful planet. Now, you might be wondering, what causes these geomagnetic storms? Well, they can be triggered by solar flares or their much scarier cousins, coronal mass ejections, CMEs. Imagine a super-duper mega-sized solar sneeze. That's a CME for you. One of the most famous CMEs caused what's often considered the worst geomagnetic storm of the 20th century, the Great Storm of 1921, also known as the New York Railroad Storm. While colorful auroras lit up the sky like a cosmic disco, there were fiery outbursts on Earth as charged plasma began to fry telegraph lines and switchboards. Radio signals went haywire too, though some got a surprising boost. This epic event might have even rivaled the infamous Carrington event of 1859, which is thought to be the most intense geomagnetic storm of all time. Now, I know what you're thinking. These events must be super rare, right? Well, not exactly. They could strike at any time, like that sneaky CME that narrowly missed Earth in 2014. NASA believes it could have been even more monstrous than the fires and auroras of 1921 if it had hit us. So, while the New York Railroad Storm might seem like a once-in-a-lifetime event, nobody really knows what the future holds. So, back in the 20th century, there was this super intense solar storm called the Great Storm of 1,921 inches, or the New York Railroad Storm of 1921. It wasn't the biggest storm ever, but it was the most severe one that smacked into Earth during that time. Now you might be wondering, what in the world caused this epic storm? Well, according to a study by researcher Mike Hapgood, it all started with one coronal mass ejection, CME, after another. But wait, what's a CME? First, let's talk about solar flares. Imagine the sun having a massive sneeze, but instead of snot, it shoots out powerful plasmatic explosions that push charged particles toward its surface. Gross but cool, right? Now, coronal mass ejections, CMEs, are like the sun's bigger, badder sibling. They're huge blobs of plasma that get kicked out from the sun's outer atmosphere, called the corona. So, CMEs are not just monster solar flares, they're a whole different level of solar craziness. You know those dark spots you sometimes see on the sun? They're called sunspots, and they can be a sign that something wild is about to happen. These cooler, darker regions are like warning flags for twisted magnetic fields in the sun's corona that are stuffed with superheated plasma. It's like the sun's got a bellyache, and it's about to let out a massive burp of plasma. Let's talk about the event that happened way back in 1921. Picture this. You're chilling in New York City, and suddenly a powerful storm starts causing chaos all around the world. No, it's not a scene from a sci-fi movie. It actually happened. This storm was so intense that it messed with telegraphs and phone lines everywhere, from the US to Europe, and even Japan and Australia. Imagine trying to text your BFF, but your phone goes all wonky because of some crazy storm. So, what caused all this trouble? It's something called geomagnetically induced currents, or GICs for short. NASA says GICs happen when plasma from coronal mass ejections, that's a fancy term for a huge burst of solar stuff, messes with Earth's magnetic field. It's like the Earth's magnetic field gets all shaky and unstable, kind of like when you're trying to balance on one foot. This shakiness causes electric currents that can really mess with our electrical stuff like phones and telegraphs. The first signs of trouble were reported on the night of May 13, 1921, all the way from Norway. Soon after, the US and Sweden started having problems too. In Sweden, it was almost impossible to make phone calls or send telegraph messages. Denmark wasn't doing much better, and Germany knew something was up when they saw an aurora light up the sky. Things got even worse on the morning of May 14th. On the other side of the world, Samoa and Hawaii were hit by the storm early in the morning. Scientists at the time used magnetometers, fancy tools that measure magnetic fields, to figure out how intense the storm was, and their readings are still considered pretty accurate today. When the sun's magnetic fields break, it pukes out tons of plasma. If that plasma gets shoved back into the sun's face, we call it a solar flare. But if it's released into space, it becomes a coronal mass ejection. And let me tell you, CMEs are no joke. They can send billions of tons of plasma zooming through space at millions of miles an hour. It's like a plasma race car in the fast lane. Even though they're super speedy, it can still take days for that plasma to reach Earth. But when it does, you better believe it's going to cause a storm like no other. Now, this light show, called an aurora, was extra special because it was way brighter than usual. New York astronomer Latimer J. Wilson was the first to notice something strange happening in the sky. It started out looking like a wispy cloud of moonlight surrounding the star Arcturus. But then, things got wild. The cloud grew bigger and changed colors like a chameleon at a rave, going from emerald to amethyst in a flash. People stopped in their tracks to watch this amazing celestial performance. At its brightest, the strange lights were even brighter than the moon. But it wasn't just the moon that got upstaged. According to the Solar Terrestrial Center of Excellence, the aurora was so bright that some stars were barely visible, and it lit up the night enough to read by. And guess what? New Yorkers weren't the only ones who got to enjoy this cosmic spectacle. People all the way on the West Coast and the Southwest, including Arizona, California, and Texas, were also treated to this light show. Astronomer O.H. Truman even captured images of the phenomenon in black and white at Arizona's Lowell Observatory and shared them in Popular Astronomy magazine. While people were busy staring at the beautiful auroras in the sky, telegraph and phone operators were freaking out because their equipment was going haywire. In fact, the storm even caused some fires. In a little town called Brewster, New York, a switchboard operator at the local train station noticed that his switchboard was literally on fire. He quickly evacuated the building and even managed to save someone who was sleeping inside. But sadly, the whole place was soon engulfed in flames. But wait, there's more. Another fire started near New York's Grand Central Terminal, you know, that big fancy train station. And yet another one popped up all the way over in Karlstad, Sweden, because of a phone system going bonkers. Now you might be thinking, why are we talking about New York so much? Well, it's because railroads in the New York area were in some serious danger during this storm. One of them, the Union Railroad in Albany, even caught fire after its telephone lines were zapped by a bunch of electric currents. This crazy geomagnetic storm caused so much destruction in New York City and the state of New York that it got its own name, the New York Railroad Superstorm. Imagine you're living in 1921, and your main way of communicating with others is through phone and telegraph lines. Now, picture a storm so wild that it fries these lines, leaving them totally useless. Yikes, right? Well, that's exactly what happened during this storm, and it was a big deal, especially for people living on the East Coast. New York, in particular, had it pretty rough. You see, back then, telegraph systems were super important for keeping trains running smoothly. And guess what? They went completely bonkers during this storm. We're talking about wires overheating and dying left and right, even the ones buried underground. The electric currents were so strong that they busted fuses and other parts of the infrastructure. Things were going haywire, literally. To give you an idea of how intense this was, some voltages shot up to 1,000 volts. Now you might be thinking, what does that even mean? Well, let me put it this way. The Energy Recovery Council warns that if you're exposed to voltages over 1,000, you risk getting some nasty burns. And the worst part? You might not even realize how bad the damage is for days. While electrical shocks at this level might not be deadly, they can cause some serious problems like chronic muscle pain, fatigue, and even the amputation of limbs with too much tissue damage. Yowza! So next time you're caught in a storm, just be glad that you're not dealing with the mayhem of 1921. Our buddy Mike Hapgood, a researcher who knows a lot about space weather, found out that this storm actually made radio signals stronger. How? Well, it's all about something called conductivity. Imagine conductivity as a magical force that helps electricity flow better. And the storm? It was like a giant battery charger that boosted this magical force. Now let's talk about radio signals. They travel in waves, and these waves have something called frequency. Frequency is like a heartbeat. It's the number of times the wave vibrates every second. The crazy thing is, the Earth's surface is also a conductor of electricity. That's why the underground telegraph lines got zapped. But radio signals with low frequency could use this conductivity to their advantage without breaking down. So they got a super boost whenever there was higher conductivity. That's why some radio signals could still travel far and wide, even when phones and telegraphs were out of order. But wait, there's a twist. Radio signals don't just travel on the ground, they also zoom high up in the sky. So when the atmosphere got invaded by solar plasma particles, sounds like a sci-fi movie, right? There was sometimes interference between the radio signals and the ground. It was like the radio waves were playing a game of dodge the plasma. Despite this, radio signals still managed to travel from Berlin, Germany, and Bordeaux, France, all the way to New York. European radio broadcasts even reached the US. And it wasn't just a one-way street. Signals were also flying back and forth between Samoa and New Zealand. So there were these astronomers hanging out at Mount Wilson Observatory, and they were trying to figure out what was going on before and during this massive storm. It's like they were detectives, but for space stuff. Fast forward to today, and some smarty-pants researchers, Lundstedt et al., took a look at the old observation data and published their findings in a fancy journal called Annales Geophysicae. They think that the storm started on the far side of the sun, which is the side that faces away from Earth. Back then, it was super hard, if not impossible, to see that side of the sun with a telescope. So this sneaky storm was born in the sun's secret hideout and grew into a huge monster before anyone could see it. By the time the storm was visible at the sun's extreme east end, it was already a big, bad space monster. And then, it decided to move to a more visible spot on the Earth-facing side, like a mischievous kid playing hide-and-seek. And finally, boom! It exploded toward our planet. But wait, there's more! Another study by Silverman et al., published in the Journal of Atmospheric and Solar Terrestrial Physics, looked at what happened when the storm's plasma hit Earth's magnetosphere. That's when auroras, those beautiful, colorful lights in the sky, started flashing like a disco party. Now here's the weird part. These auroras happened even at low latitudes, which means they were seen right above and around the equator. That's super rare. It's like the storm was showing off, trying to see how far its atmospheric effects could go. What a show-off, right? Let's talk about a time when some smarty-pants scientists actually doubted the one and only Albert Einstein. Can you believe it? Back when his theory of general relativity was just a baby idea, a few other scientists were like, nah, that can't be right. One of them even tried to use the pretty lights in the sky called auroras to prove Einstein wrong. Spoiler alert, they didn't succeed. So what's this relativity thing all about? Well, it's a super cool theory that's all about gravity. You know, the force that keeps your feet on the ground and makes you fall when you trip? Einstein had this amazing idea that went beyond the usual thinking that gravity just pulls smaller things towards bigger things. He said, hey, what if gravity actually bends space itself? And the bigger an object is, the more it bends the space around it. So the reason planets in our solar system go round and round the sun is because the sun is like a cosmic bowling ball, bending the space around it and keeping the planets in their orbits. Mind-blowing, right? Now picture this. Einstein was about to head to New York City to give some fancy lectures when a big storm hit in 1921. Before his theory of general relativity, physicists believed in this thing called the ether. Nope, not the stuff that puts you to sleep. This invisible, ghost-like substance was supposed to fill the entire universe, and everything was just floating around in it. But Einstein came along and said, nope, there's no ether, and actually my theory needs it to not exist for gravity to work its magic on space. Well, one professor was super shocked by this and just couldn't let go of the ether. He looked up at the auroras in the sky and thought, aha, that must be proof of the ether. But guess what? He was wrong. and Einstein's theory still stands today. So remember, even the smartest people can have doubts, but sometimes you just can't beat a good theory like Einstein's. Picture this. The sky is on fire with blood-red auroras, making people think there are huge fires in the distance, or even that the apocalypse is coming. That's what happened during the Carrington event. The light from these auroras was so bright that it woke up people and animals in the middle of the night, tricking them into thinking it was morning. The air was so charged with electricity that it seemed like everything could burst into flames. Circuits went haywire, sparking like crazy, and the paper that telegraph operators used to record messages even caught fire. Now let's talk about the 1921 storm. The big question is, could it have been as powerful as the Carrington event, or maybe even more powerful? Well, we're not quite sure. The problem is that we don't have enough data to prove which storm was stronger. Back in 1921, they didn't have the super cool astronomical equipment we have now, so the storm might have been underestimated for a long time before scientists looked at the data again. Figuring out how strong the Carrington event was is also tricky. We know it was intense, but we can't pin down an exact number. The 1921 storm's strength is not exact either, but it's a bit more accurate. When some smart folks like Love and his colleagues did the math, they found that the 1921 storm's strength falls somewhere in the middle of the Carrington range. So there's a chance that the Carrington event could be dethroned as the most devastating solar storm of all time. But unfortunately, there's just no way to confirm it for sure. Our pals at NOAA have this super cool scale for measuring geomagnetic storms, and they've been thinking about what would happen if an extreme storm hit us. Back in 1921, people were mostly worried about their phone and telegraph lines, but today, oh boy, we've got a whole lot more to worry about. You see, we're super dependent on electricity and power systems now. If a massive storm like that hit us, anything that needs to be plugged in would be toast. We'd have crazy voltage problems, and entire areas would be left in the dark for days, or even longer. But wait, there's more! Our satellites and other space buddies would be in big trouble too. The storm would make them go all wonky with plasma overcharging, and they'd be thrown off their orbits. So even if our computers on Earth were still working, we'd have a hard time keeping track of those poor satellites getting lost in space. And it's not just satellites that would suffer. NOAA also reminds us of a spooky solar storm that hit Earth just before Halloween in 2003. While it wasn't as bad as the one in 1921, it's still one of the most intense storms we've seen in recent years. This crazy event was caused by two coronal mass ejections, which are like giant solar burps that triggered two geomagnetic storms one after the other. The storm was so powerful that it fried an instrument on NASA's Mars Odyssey orbiter and forced astronauts on the International Space Station to hide from dangerous radiation. Back on Earth, planes had trouble flying, communications went haywire, and GPS systems went berserk. Wow, what a journey. We've learned about the Great Storm of 1921, its causes, and the incredible auroras that resulted from this massive geomagnetic event. We've also explored how the storm affected telegraphs, railroads, and radio signals back in the day, and how the Carrington event might be dethroned as the most devastating solar storm of all time. Most importantly, we've discovered just how vulnerable our modern technology is to such extreme solar events. So, what do you think? Are we prepared for another massive geomagnetic storm? Share your thoughts in the comments below, and don't forget to hit that like button and subscribe to our channel for more exciting space adventures. Stay curious, and we'll see you in the next video.